Hello and welcome back to Steam with Steve. Today we're going to go through the assignment that students are going to follow, where they're going to learn how to build their own retro game. They're going to learn how to code in Python to do this and use the Pygame library to achieve it. So let's jump on in. The assignment basically follows on from all the work that we've done already this semester, where they've learned the Python library and how to do if statements and loops and all these type of things. And they've all had to go using the Pygame library to build Snake. So they should all be aware of how the library works, and then more importantly, what options are available to them. So let's jump on in. So the learning intentions today basically is to go through all the sections of the assignment and also what the assignment is and why we're doing it. So first of all, we're going to do a retro game design brief to talk about what the scenario is and the settings are, what section A is, and where they analyze different games. Then section B, where they design their own game. Then section C, where they build their own game. And then lastly, section D, where they do the review. Now you see there's an example here of Space Invaders, where basically there's a little starship down the bottom where the player can control to go left and right. And then there's the lives, the score, and all the enemies. So we're going to talk about how do we analyze these games and what's the actual algorithm that's happening behind the scenes. So why are we doing this? Well, the gaming industry has gone up exponentially over the last couple of years. So if you went back 20 years into 2001, the budget or the amount of revenue that was generated from video games was equivalent to the music and film industry. Okay, so now going into the 2023 sort of era, it's more than double. So and that's combined music and film. So video games is a huge growth opportunity. So even if you aren't a programmer, there is a lot of things that you got to do behind the scenes. So graphic artistry, the finance, there's heaps of different industries that sort of link into that ecosystem. But if you understand how a game is built, that gives you a huge opportunity and a big advantage compared to all your different competitors that are out there. So what's the design challenge? Well, we're going to get you to build your own retro game. Now, here's basically what I've made up. So as an experienced Python game developer, Atari has employed your company to revitalize the classic arcade experience. So your mission is to create a retro-inspired game with authentic 1980s aesthetics and nostalgic gameplay. So you could build Snake, there's Snow Brothers there, Pac-Man, Donkey Kong, there's all those different retro games that came in that time frame. And they've got a really cool game mechanic that's easier for us to sort of understand compared to the more high-level games like Fortnite and etc. So they're all sort of 2D games, but they're a lot of fun, and I think you'll learn a lot by playing through this. So this is the design cycle that we'll be following with this assignment, and it maps against the NESA curriculum where we identify and define, which is what the section A is, research and planning section B, and then producing and implementing in section C, and then section D, where we test and evaluate. So when we are in the identifying and defining phase, we're going to analyze 3 different games, tutorials where you get to learn how to build Pac-Man or Donkey Kong. We're going to then mind map out what your game will look like and all the different sort of add-ons that you might put into it, followed by a design brief where you might do like a little elevator pitch of what your game is going to be, and then a design criteria where you'll list a couple of elements that you need to do for your game. When we move into section B, you'll do a storyboard, so you'll map out what the scenes will look like inside of the game. Then you'll do the NESA pseudocode for it, which will show exactly how the game code should look. And then a Gantt chart, which should go through and explain when all the key milestones will happen with your game. Then in section C is the fun part, where you get to go off and actually build it, and you'll be marked for the code design, the complexity and the uniqueness, the programming skills that you do with Python, and then also the design follow that you put together. And then lastly, in section D, you'll go off and test and evaluate. So this is where you'll review the design criteria that you set up in section A. You'll then do a Google survey and get some data back from people testing your game. And then lastly, you'll write that little final review of your game, which is pretty cool. So here's some other examples of retro games. There's Breakout, there's car racing games, Frogger, Asteroids, the list sort of goes on. So really important, make sure you choose the genre that you're actually interested in, and also check with your teacher whether or not they feel that you're going to be able to achieve the game. So don't forget, you only have this much time. Make sure you don't choose a game that's going to take you this much time and sort of be a bit beyond your skill level. So try and choose something that is sort of challenging, but also reasonable for you to achieve. So let's unpackage a little bit further all these different sections. So we're going to start with section A with the identifying and defining. So in this, we're going to go through what the game tutorial reviews will look like, then the mind map that you'll put together for your game, then the design brief that you'll put together, sort of outlining how the game should look, and then finally the design criteria, which will be that sort of IKEA checklist of all the things that you want to happen in your game. So this is the most important slide for the next for your project to come together. So it's really important that you follow this. When designing your game and building it, make sure you use tutorials as a starting point. So you're not expected to build a brand new game from scratch with no sort of experience in anything else, but you're expected to sort of use those tutorials and look at ways of extending it. Now, if you just follow the tutorial and sort of copy and paste and get through it, we will definitely pass you. But if you're looking for the A's and the B's, we're looking for people that sort of extend what they already know and try to incorporate it. So there's an old saying in computer programming is don't reinvent the wheel, and that's what we're doing here. So someone has already gone off to the extent of working out how to build Pac-Man. So instead of you having to work out all the stuff that goes on behind the scenes, you can just use these tutorials and sort of go along the way, which is pretty cool. So I've done a list here. There's probably about 30 of them that I've found, and I've rated them from difficulty ranging from easy, medium, and hard. So up the top there, you'll see 5 really good tutorials that sort of extend your Pygame experience if you want to have a crack at those. And then underneath that, a whole list of them. So ranging from Tetris, Flappy Bird, Hangman, the list sort of goes on. So it also gives you the duration. So for example, Flappy Bird probably takes about 1 hour to complete, which is why it's rated easy. When you compare that to something like Donkey Kong, which is pretty hard, and that takes about 4 hours and 48 minutes. So make sure you choose something that is challenging, but also something that is reasonable that you think you'll be able to achieve in the time that you've been given. So the tutorials, these are the ways that we've sort of reviewed. So I'm not expecting you to watch the whole 1 hour tutorial, probably about 15 minutes of just sort of skim read through it and sort of slide around until you find the key information and looking at it, whether or not that you'll actually be able to achieve that, building that tutorial. So it's really important that we do these reviews first before we go off and actually select the game tutorial that you're going to do for your final game. So the game tutorial review, basically the first thing is that you'll say the name of the tutorial, then a screenshot of the tutorial from the website, then the URL for that YouTube or link that you followed. So you might actually find a text version, which is fine. Then you're going to go through the colors, the sounds, and the fonts inside the game, and then a description of the gameplay, which is like the levels, how does the graphical user interface look like, what's the controls. And then after you've done that, you need to at least 3 pros and cons for the tutorial. So what's good and bad about it. And then after that, summarize what was important about the tutorial for you, and then describe what you might use inside of your game. So the purpose of this is to identify and evaluate key elements inside of the Pygame tutorial, develop an understanding of the game development, so such as colors, sounds, and the gameplay, and then analyze the pros and cons of the selected tutorial for making that informed decision at the end. Some questions that you might want to think about while doing this is how can the elements of a good Pygame tutorial influence the success of your game project? What aspects of the game development do you find the most challenging and why? And then discuss between yourselves how the skills learned today can be applied in your future game development project. The next section that we follow is the mind map. I personally like using the Miro product because it's really, really good. It goes through pretty clearly exactly how to link all the pieces together. And yeah, I'd highly recommend that. So with this, we will understand the structure and purpose of the mind map. So you will start with your central idea, then you might branch out with your player controls, the graphics, the enemies, all the different sort of components that are inside of the game. And then just try and branch out, be as creative as you want. And then at the end, we'll start filtering it down. So you create a mind map using the Miro to work out that retro game, which helps you identify those key features and then aspects necessary for designing your retro game. So some things to ponder while you're doing this is how can the skills learned while creating these mind maps be applied to other subjects and projects? What are the most challenging and rewarding parts of using Miro for your game concept? And then you might want to discuss how the mind mapping can be help organize your thoughts and ideas in complex projects in game design. So we'll probably spend one lesson for each of these items as we're going through. And then that way you can sort of map them out, talk to your peers, also to your teachers, so that you can understand what needs to happen. Now, for this part, basically in the rubric, you'll see that there will be a marking scheme, and they'll be rated from 5 all the way down to 0. I'm going to go through what a 5 would represent for those two things. So to achieve a 5 for that, you need to demonstrate an extensive understanding of the influence of enterprise innovation and automation on the evolution of computer technology. So what that means is your ability to extensively analyze the 3 Pygame tutorials with detailed pros and cons, and then get that comprehensive mind map together, which shows an in-depth account of the situation. You're then going to skillfully apply appropriate iterative processes to produce an advanced computing solutions. So by using that mind map, you're going to filter down all the stuff that you looked at with the analysis and try and make some really clear links between them. Cool, so then the next section is the design brief. So this is like the back of the box of the game if you picked it up in EB games. So this is where you identify the key features of the game, and then all the different elements of who's the game been built for, what are the competitors, so similar games, and then any constraints and limitations that you might have. So what's the time frame, your budget, do you have a whole huge team developing this, is it just you? You need to think these all through. So it gives you the ability to develop an understanding of how to create a design brief, which, like I said before, it's sort of like your 10-second elevator pitch. So if you had to try and convince someone that if they had $1 million to invest into your game, why would they do it? And then this is what the design brief does. So you learn how to identify the target audience, the competitors, and also any of the constraints that you're facing. You then understand the importance of developing the planning of your game development, which is really, really important. So the more time you spend planning, the easier it is when it comes to actually building the game, which is what all these tools are sort of building up to. The next part then is your design brief. So, within inside the design brief, when you're considering it, you might want to think about how can the skills be learnt in this project be applied to other software development aspects? What are the most essential elements inside of the game design brief? And then how can your effective time management impact the success of your project? So if things get delayed, will that have a critical impact onto what you plan to do? We then come onto the design criteria. So this is the next part of this section. This is a really cool thing that gives you an idea of all of the things that you want to achieve. So it's basically like a little mud map where you list 10 items of the things that need to happen inside of your game to be successful. So you might see there's the player character, and then this person's gone through and described how they're going to handle the player character when they actually go off and build it. So I can find what they've said is they're going to use assets that they found online for multicolored sprites, so that the background sort of stands out compared to the player. And then the player is going to need to be able to walk, jump, and cling to walls, and then dash around the levels. So it's a pretty good description of what the player character needs to do. So these help you understand the design components that need to happen inside the retro game. Helps you develop a detailed checklist so that when you go off and actually design and sketch out your storyboards, you've got a really clear description here. And then helps you apply creative and technical skills to conceptualize the game elements. Some things to consider here is how can the design criteria that you've developed be adapted for different types of games? What challenges might you face in implementing these criteria, and how will you address them? And then how can the skills learned today be applied in other areas of technology and design? Some really helpful hints when the first time that you do design criteria can be a little overwhelming. So this is why I've created this slide. So basically you want to focus on the features and then also the benefits. So features are like how you're going to achieve this, and then the benefits of why this is a good thing. Okay. And then the rating that you'll do eventually for this criteria is something that will happen in section D, where you'll review them at a milestone point, probably 2 weeks before it's due, and then when it's actually due. So this sort of keeps a little bit of accountability for yourself, so then you're aware, how am I actually going to get this across the line? So make sure that you use fab statements, which is the features and the benefits. So remember, people buy benefits. They don't really care about the features, right? So they're always going to be asking, what's in it for me? And what's so good about this fancy new feature that you're putting together? So a really good example of a fab statement might be multiple levels, which is the feature, means that players are challenged and therefore motivated to keep on playing, which is then the benefit. So here's a marking guide for those two pieces of the design brief and the design criteria. And then this is what a 5 out of 5 would be. So perceptively analyzes a chosen Python game by constructing an extensive design brief for a challenging and meaningful gameplay algorithm. Extensive design criteria describing a complex and engaging algorithm, and then independently and logically lists at least 10 design criteria elements with innovative ideas all the way through. Cool. So now we move on to section B. So we've done all the analyzing. Now we're going to actually research and plan how we're going to implement this game. So the things that we're going to do is a storyboard, which gives us a sort of a picture version of what the game will look like. A flow chart, which then shows sort of the algorithm behind the scenes of what's happening. We're then going to actually build the pseudocode for your game, which is similar to the Python code, but a bit more written like English. We're going to use the Nessa framework for that. And then lastly, we've got the Gantt chart, which is where you're going to build the clear guidelines of what you're going to try and do, and then also have critical milestones along the way so you know when you're going to finish it. So to start with section B, the storyboard, it'll look something like this. You can use this template or you could use another one if you want. Check with your teacher. And what happens here is at the top, you've got the title that says the starting screen. So this is what it's going to be. A little picture, so you can either develop this in Photoshop or hand draw it yourself. And then what happens there, it gives a really clear indication of what the screen should look like. So underneath it gives a really detailed description. So the start screen will be dark green. With the game, Snake game titles, you'll use the arrow keys to change between the different settings. Once the difficulty is chosen, press the enter key. So that gives a really good understanding of what actually happens in that scene, and then also the interactions from the user. So the storyboard helps you understand the components of the basic game design, and then also learn the key elements of the game's interface, including the start and the instruction screens that you'll need to build. You also then will get some insights into the basic gameplay mechanics, and then also how does the game over scenario sort of come together. And then also you'll build this whole simple storyboard. So you should build at least 4 slides here so that you can clearly see the start, the instructions, what does the gameplay look like. You might have a couple of different levels, and then also the game over at the end. So some questions to ponder here. How could the skills learned in designing this game be applied to other types of games? What were the most challenging aspects of creating your game storyboard and why? And then discuss how understanding user interface design can be beneficial in other areas of technology and programming. Now we'll move into the flowchart. So this flowchart here is a really good example of how Snake sort of works. So you got your game start point, you initialize the objects, you start rendering the game, and then if a new selection has been chosen, you'll change the direction, otherwise you won't. You'll then move the game, check for any collisions, if it's collided with the self, the wall, or the coin. If it's hit the coin, you've added some points, respawn the coin randomly, and then you go back to the render. As soon as it hits either itself or the wall, then you end the game, and then you come back, wait for that reset, which could be some sort of menu option. So that's a really simple flowchart that gives you a pretty good detailed understanding of how the game sort of looks, and that's what we'll be expecting you to do. So you'll need to go through the tutorial and sort of break it down into these main sort of big ideas of how the game would look. So then you can understand the basics and the importance of the flowchart in your game design, learn how to create detailed flowcharts, which will be important all the way through your programming career. And we'll use a program called draw.io to get your mind into the game with that. You'll then develop a flowchart with a simple game, and then consider the gameplay mechanics, and then analyze an example flowchart, which is what we just did there with the Retro Snake game. So some things to consider when you're thinking about the flowchart. How can flowcharts be used with other aspects of programming or project management? What are the challenges did you face when creating your flowchart, and how did you overcome them? And then how could your flowchart that you created be expanded or refined for a more complex game? The next bit then that we'll build is the pseudocode. So if you've done all the hard work with the flowchart, the pseudocode actually becomes a bit easier. So if you look here carefully, it actually mirrors it quite pretty much exactly the same, but it's all in the text written format. Now this is where you can just give the big ideas so that when you go to actually code it, it's a lot easier. So in this case here, we've got the begin snake, where we initialize the game variables. We then create the game board. We then set the initial position of the snake, which then generates the food item randomly on the board. And those are all big ideas that need to be defined a little bit later. Okay. Now you can unpackage that further if you want, but this is sort of what we're expecting, so that you get an overall picture of what the game should be. Then you have the main game loop, right? So while the game is not over, display the game board and the snake, get the player's input, so is it going up, down, or left, or right? And then if the snake eats the food, then you're going to increase the length of the snake, generate a random food piece on the board somewhere, and then update where the snake's position is based off that player's input. If the snake has then hit the wall or itself, then you set the game over variable to false. To true. So then it's basically game over, the loop will end. You then delay for a short period so to control the game speed. So you might have 60 frames per second and all those type of things. That's what that delay is. So you might hold it for 1/60th of a second so that it allows the game to sort of render. And then you end the while loop, display the game over message, and then there's an optional ask the player if they want to play again. Now you'll see here there's very clearly ordered pairs, so it's a little bit different to Python. So the while loop, for example, has a while, but then it has an end while. That's so that you know inside this is where the while is happening. Similarly, the if statement looks a little bit different. Instead of the colon or the snaky bite at the end of the if statement, you use then, and then also you use the end if to signify that that's connected. The reason why NASA does this is so that when you're handwriting it, it's very clear where your if statement ends, and there's no sort of miscommunication or confusion on that. Okay? So the pseudocode, we unpackage that a little bit further. It helps you understand the concepts and the purpose of the pseudocode. Learn the NASA pseudocode guidelines, then you apply the pseudocode to this retro game, then develop logical thinking, problem-solving skills in the programming, which is kind of cool. So some things to consider when you're doing pseudocode is how can the skills learned in pseudocode actually help with the coding that you're going to do? What's the key concepts of an effective pseudocode that you build? And then what can pseudocode be applied to in other real-world scenarios? So how does that logical sort of style of thinking help in your day-to-day and everywhere else? Now those three things will all merge together in one mark, so the storyboard, the flowchart, and the pseudocode. So to see what happens if you wanted a 5 out of 5, you need to have an extensive annotated storyboard with flowcharts and pseudocode depicting all the functions of the gameplay algorithm. You need to then develop highly effective computing solutions using advanced computational design and system thinking skills, and then demonstrates creativity and innovation in algorithm design. So this is where you get to show what's sort of the extension things that you're going to apply to your game that have come from the tutorial. So that might be adding extra levels, different enemy types. You might also think of different bonuses and power-ups. So there's a whole heap of different things that you can think here. And make sure you talk to your friends just about how they're doing it, because they might have ideas that might help you as well. The next section, B part, is the Gantt chart. So this is on its own line because it's that important. So the Gantt chart basically is your milestone point, which keeps you accountable for all the things that you plan to do. So if you've done the pseudocode, you've done the flowchart, you've done the design criteria, you should understand all the parts that need to happen to actually build your game. And so inside this part here is where you're actually going to say, I'm going to try and achieve this on this date or over these couple of days. And this helps to keep you accountable throughout the process. So you'll find that your teacher will check in with you as you're building this, so that they know where you're up to, and then they can give you a bit of feedback to say, hey, you might need a bit more time here, or similarly, you might need to spend a bit more time on this part. It's really important that you try and detail this. This is not an assignment that you can do the night before. Not that that's a challenge. Okay, so it helps you understand the concepts and the purpose of the Gantt charts in project management. You learn how to create and interpret the Gantt chart using the provided template that I'm going to give you. And then you develop the ability to organize tasks and timelines effectively for your project. You'll also get the appreciation of the importance of this visual tool when you're going to manage more complex projects in the future. So by using something like this, it makes it so much easier to see when things need to happen and gives your brain a bit of a relaxation instead of being overwhelmed. Some points to ponder with the Gantt chart is how could you use a Gantt chart in your own life for planning for exams or a personal project, encouraging the students to think about how this tool can help in other subjects, and then what is the most challenging part of building the Gantt chart, and then how did you overcome it? Like I said, this is very important, so it's got its own 5 out of 5 opportunity for you. So this is what you need to do. So independently and logically creates a comprehensive Gantt chart listing all complex tasks necessary for the complete production of the Python game. They need to demonstrate advanced project management and organizational skills. Pretty simple. And then move on to the fun part, the section C. So this is the producing and implementing part. Now with this, there's only really one artifact that you need to produce, which is the design folio. Now this is sort of like your captain's log. While you're building the game, you need to have a detailed description of what you're doing on each day. So it's very clear to me how hard you've been working. If you don't fill in the design folio and you hand in this amazing game, it's really hard for us to give the marks because we're not sure whether or not you've just copied and pasted it from somewhere or you've gone ChatGPT to print out the whole thing for you. So you need to be really mindful inside this design folio to show how hard you worked, okay? And we really want to see how much you struggled as well. So what things happened that went wrong, and then how did you overcome that? That's the really important part with this design folio. Now we've produced a template for you to fill in. Basically at the beginning of the lesson or whenever you're going to do some work on this, you'll write your plan description. So this is where you get to write your intention. So it can be 1 to 2 sentences saying what you're going to try and do. So for example, we might be trying to build the player controls so that WSD will work for the game. After you've done that, then you'll go off and actually code, do the work that you wanted to do. And then as you come to the end of the lesson, you need to then describe the challenges that you experienced and then what you learned from those challenges along the way. If you don't fill that part in, it's really hard for us to give you the high marks. So like I said before, it's very easy to pass. If you've done the work, you'll get a C. But you need to show us the struggle that you faced and then how did you overcome it to get those A's and B's. You then need to say the time taken, so how long did it take you to do, and then any resources that you needed. So any tutorials that you followed, electronic images, basically you need a list inside of that. After you did that, you then would put the screenshots, so any of the code that you did or any of the images from your game. So this gives us the ability to understand the purpose and the importance of what you've done. That's what the folio does. It then you'll learn how to document your ideas, your plans, and then also any practical work that you did. This is really important if you want to become a software engineer in the future, because it's if your code gets corrupted, for example, you then at least have a process journal to go through and work out what you did, and then all the resources that you tried to use along the way. It's also really important to show to your boss that you've done the work, so that they understand, oh yeah, they actually know what they're doing, and then you've described what you've done. So this also gives you the ability to recognize and articulate the challenges that you faced along the way, and then how did you overcome them. And then you develop organizational skills by regularly doing this folio update. So this is very important that you make sure that you fill this in as you go. This is a pretty good example of high-level student that did the work. So this is where they talked about creating the Pygame window for the startup. Then they went through the initialization of the Pygame window, making sure that it had a constant rate for the frames per second, and then did additional code for the structure of the background started. It's okay if your plan doesn't always have a changes to plan. So this was a pretty easy task for the student to get across the line because they're pretty much copy and pasting. But it's very, in the long run, there needs to be a few more changes that you face along the way. Okay. And then they've put an image there of a screenshot showing how the game looks and what happened along the way. Cool, so some questions to ponder with this is how will you maintain a detailed design folio to benefit your future projects? Can you identify any real world things that have come along the way where detailed documentation would have been useful? And what strategies will you use to ensure your design folio remains up to date and comprehensive so that it's clear all the way that you're doing while you're doing this? This one has marks that you can get four set parts that you can get 5 marks in each. So we're going to go and package each one. So to get 5 marks for the game algorithm design, you need to have an extensive game design showcasing superior software engineering skills, which is what that changes to plan section is. So you need to demonstrate an understanding and application of computational design and system thinking skills in developing highly effective computing solutions. So if you don't describe the challenges that you face, it's hard to say that you're extensive in this part. The next part then is the game algorithm creativity and innovation. So what did you do to extend what the current tutorial was? So it demonstrates an extensive level of originality and critical thinking in the development of creative and insightful concepts within the game algorithm. Shows creativity and innovation in design and implementation of user interfaces for engaging user experience. So what did you do to make that user experience really, really cool? So that's what you would need to do to get the 5 marks. The next part then is the programming skills that you learned in Python and Pygame. So skillfully develops, tests, and implements technically concise algorithms. So are they the most effective way of coding that you've done? And then demonstrates high proficiency in programming and technical documentation. Now, technical documentation is a little bit different to the documentation in the design folio. Like your comments, your use of variable names, how have you coded? Is the indentation right? Have you used functions in the right way? That's what needs to be happening there with your programming skills. Then the last of the 4 things is that you can get 5 marks for is the design folio mark. So this is where you independently and logically communicates the features of the Python game and then describes complex ideas. Skillfully applies appropriate iterative processes in the design folio. So this is where you get to showcase what did you actually learn along the way, and then show me the struggles that you faced, and then how did you overcome them. Cool. So now we're moving on to design, section D, which is the testing and evaluating phase. And this part here, you'll do the milestone design criteria review. So you should do that at least 2 weeks before. If you want to do it earlier, that's fine. But you need to have at least one of these milestone review sections. You then need to do the actual review at the end once your game is finished. So then you can say these are the things that improved. And by having that milestone review compared to the final review, gives you that opportunity to show how much you improved along the way. You then need to create a survey and hand that out using either Google Forms or other surveying software. Then need to get those results to show what you did, and then have a self-reflection of any improvements that you could have done for the game. And then at the end, you need to write your final report. So the final report takes all that data that you've collected, and then you need to actually put that in a written document so that you can show what you do. When I personally mark this assignment, what I always do is read the final report first, and then I go back and see if there was some data that goes into that. So have a think about how you're going to do that. So unpackage the first thing with the milestone design criteria review. Basically the criteria that you set up before. You give yourself a little rating. This person's used a scale of 10, so they gave themselves 5 out of 10. And then they've done a bit more than what was expected of them, and they've actually described what they've, how well have they actually achieved that. So this gives you an understanding of the importance of milestones in the project management process. You learn to evaluate and rate the design criteria effectively, and then you differentiate between milestones and then that final design criteria review that you're going to do. And then that gives you the ability to do that self-assessment on what you're doing inside of your project to improve it. Then with the actual final design criteria review, things may change, things may not, that's fine. But because you've done all the hard work before, I think in this one here, the main characters is different. So they actually did improve inside the main character what they did. So the main character basically was better. The collision, I think, from memory when the student did it, had improved. So you learn how to evaluate and rate the criteria more effectively by doing it again. You then differentiate between the milestone and the final review. And then you again learn how to apply that self-assessment on what you've done. Some things to consider is how can setting milestones help in other areas of your life besides the school project that we're doing? And what did you find challenging about rating the design criteria? So how are you honest about what you actually did? How can the skills learned today be applied in future algorithm development projects that you might want to do? And then how do you think by doing that reflection will improve your future projects. The next part then we need to do is the survey. So the Google Google Forms is what I personally like, just because it's quite easy and very user friendly with the way that you do it. So you understand the basics importance of how to fill this in, and we'll go from that. So the survey that we need to do, you'll log into Google Forms, which is pretty easy. Basically, you need to use a Google account. And once you get there, you just click on start a new form. So you select the blank form and then go from there. From that, you'll then have the drop-down box. And then inside that, you can choose either a short answer, a paragraph, multiple choice, check boxes. There's a whole heap of different options. So choose the different type of questions by clicking the drop-down box. Make sure I have a good mixture of the types of questions and from closed and open style questions. So closed questions are usually multiple choice or check boxes, whereas the open style is more sort of what improvements do you think might happen, where you'd have either a text box with a short answer or a paragraph to get them to fill in. Once you've created it, you then gather the data. So you click up the top here. You'll have your 10 questions that you've created. You then click on the send button. You can either email it directly or copy the link to send out to people. And then you need at least 3 people to answer this survey. Now, the more people you get playing the game, I would recommend that. Whether or not you can create a copy of your file, share that around when it's compiled, or simply inside a class, hand it around. Try and work inside of teams, so then you can answer each other's surveys, which is really, really useful. Once you've done that, you can then gather all the results. If you're using Google Forms, it's really easy. You can actually just click on the copy button once you're looking through these results, and it'll copy the image that you've done. The text is a little bit harder, but that's just a simple either drag or drop, or use the snipping tool to collect it. So this helps you see all the different results and then compare against each other. The last bit of the data gathering is the self-reflection. So this is where you look for different improvements that you might want to do. So this helps you understand the importance of self-evaluating inside of your game development. Then you analyze the feedback and survey data. So you identify areas of improvement and then reflect on the challenges and achievements that are achieved throughout the use of this game. You then get to learn how to prepare a concise and honest final report for your game project. So these improvements don't have to be wishy-washy, but they need to be to the point of what could be done to improve the final game. So some questions to ponder with this is, how can the skills learned in game development be applied to other areas? In what ways did the survey data change your perspective of your game? And what's one major takeaway that you would take from this before writing your final report? So the self-reflections help you think what was actually important before you write the final report. So to mark all this data collection, to get the 5 out of 5, you need to perceptively analyze an extensive design criteria review and survey questions with detailed responses, and then have a comprehensive list of improvements for your Python game. You then apply safe, secure, and ethical practices in the use of the data that you collect. The last one then is the final report. So this is the big hoo-ha after all the work that you've done. So the final report helps you understand the importance of self-evaluation in game development. You then analyze feedback and survey data to identify areas of improvement, reflect on the changes and achievements experienced during the game creation, and then prepare a concise and honest final report on your game project. So some things to think about here is, make sure you analyze the data that you've collected in the critical review part, the criteria, so listing the milestone, and then the final part, listing the improvements that you'd like to build inside your game. So if you're smart, you'd ask your friends, what would you like to add to the game? You then have your game published either online or handing it around inside a class, and then make sure you write your review as honest as you can. So make sure it looks very clearly how the project was. Was it a success or was it not? And then back your statements up with the data that you've collected. So don't just say that it wasn't good or it was good. Say why it was, and then use all the data that you've collected in the previous sections. So to get the 5 out of 5 for this final report, you need to do an extensive level of originality and critical thinking, and then providing a range of creative insights about the Python game created for the given scenario in the final report. You need to select relevant data, media, and processes to effectively communicate information in various contexts. So some critical elements to think about overall for the whole thing. Your game needs to have a whole heap of multimedia inside of it. So you need to work out the images you're going to use, either finding them on the net or designing them yourselves. Looking at the sounds, you could even create them inside of Audacity. Have a clear goal of your game. So it shouldn't just be the platform playing of the game. There needs to be an objective that needs to happen behind the scenes. A title page to welcome the players to your game. Instructions detailing how to play your game. And then an appropriate ending to your game. A copy of your game must be then shared online for others to play, so that or handing it around inside a class so that others can see what you did. So good luck. If you have any questions, feel free to talk to your teacher or your peers. There's heaps of information online about Pygame. It's really, really handy out there. And we really want to see some awesome games that you really love to do. So that's everything from me. Hopefully you've got some insights of what this assignment is. There's a lot of really cool, neat learning that happens inside of this if you lean into it. But it's really important that you've done all the work before. So if you should have done all the tutorials, learning how for loops work, if statements, all that stuff now gets used in a really productive way so that you understand why it's actually important. So I hope you've enjoyed. Make sure to give us a like and subscribe down below so that help the YouTube algorithm so more people can see what this assignment's about. And all the best. Good luck. Thank you very much. See you next time. Bye.